Hi, this is an attempt at putting together exercise 11 on a lab manual, which is on superposition. I will run through each one of the steps and try to glue all these little pieces together into something that may or may not make sense for you as students watching this thing. Anyway, if you would look at your lab manual, you'll see on page, starting page 83, but 84, we start into the lab on superposition. Superposition requires two voltage sources, and so we'll be using both sides of our triple output power supplies. We do have two independently controlled voltage sources on those supplies, and I'll show you how to configure that in a minute, although the unit I'm using is slightly different than yours. It does have the same features, so you should be able to translate it. We'll be looking at a circuit that looks something like this. Note the component underlined in blue is one that I've changed because I don't want to do exactly the lab that you all are doing, so I've just substituted a component value so my numbers will be off from what you would expect to see. But otherwise, we've got the 12 volt and the 6 volt sources along with a 1 and a 2.2K resistor along the top. The 4.7K in your lab will be a 1.5K resistor. We will be connecting up the entire circuit, but first we will connect it as if only the second source exists and then only the first source exists, and then of course we'll add those values together, compare them, and hopefully they will match with what our overall circuit values would be. So let me get some stuff together here and we'll start up again in this. Okay, this is the front of the power supply I'm using. You'll notice that it's radically different than yours. It's just made by a different company, but it's built to pretty much the same specs. We've got a channel on this side and a channel on this side, and instead of calling them A and B, this particular manufacturer happens to call them master and slave based on another function that this thing provides. You'll notice that we have two voltage control knobs and we have two current control knobs that work exactly the way ours do. In my case, I turn the current knobs all the way clockwise so that I can get the maximum current possible. This system has two voltmeters that are switchable also to amps. So I've adjusted the master voltage to 12. Actually, I've adjusted it with my handheld meter, so I know that even though this says 12.1, it's actually at 12. And I have adjusted the slave, or the second power supply, to 6 volts. You'll notice that in the middle of the two power supply controls, I've got a setting for, well, they're push button switches, and it says independent, series, or parallel. I have both buttons out so that I am in the independent mode. Series hooks the master into the slave so that I have two power supplies working off a common center point, and in parallel then both the grounds would be connected together, but then I'd be controlling both power supplies with one voltage control, so I'd have the same positive as negative. Leaving them independent, I have again independent voltage sources. So that's what I'm doing. In my case, I want to connect both of the ground leads together because I'm using a common reference or ground, and then I'll connect the master into the 12 volt point, so that'd be VA, and the slave into the 6 volt position, so that is VB. Okay, this is the course of close-ups. So we have our circuit. Our original diagram had a 1K resistor and a 2.2K across the top. And then you have a 1.5K here. I have a 4.7K. But notice both black leads are connected together, so I've got a common ground. That corresponds to the minus side of both power supplies. I have the plus 12 volts into this side, and the plus 6 volts into this side. So this is the entire circuit of figure 11.1. Our first part of this is that we will remove the 6 volt supply, VB, replace it with a short, and I'll connect that up in a second and show you the circuit. And then we'll be taking some measurements. We will take measurements of the voltage across the resistors, V1 or R1, R2, R3, so we'll get V1, V2, V3. They also note in step 2 of the lab that we want to measure or to mark the polarity of each resistor voltage on the components in that figure 11.2 so that we know which polarity we're using. Like I've said in class, that becomes critical when we start figuring out whether to add or subtract the voltage. Again, here's my circuit. I have the 12 volt source on this side, the 6 volt source on this side. So what we want to do is remove the 6 volt source, VB, and replace it with a short to ground. And so to do that, I'm going to plug a wire into the ground bus right next to the negative lead here, where I've got that plugged in. These are all connected together, and then I'll connect it up here. And then what I'm going to do is go through and to measure the voltage across each one of the resistors. I will opt to make the most positive side of the voltage across each resistor pointed toward the red connection. So we've got 12 volts coming in here, so this will be how I'll measure voltage across resistor 1, then voltage across resistor 2, or I guess that's 3, and this is voltage across resistor 2. And hopefully we'll see that the voltage across resistors 2 and 3 are the same. But I'll move things around so you can see the measurements that I take. Okay, looking at step 1, we were to construct the circuit in 11.2, so I've got the short circuit running across here where voltage source B, power supply B, would have been. And then we're going to measure the voltage across each resistor. I'll start by measuring the voltage in at the power supply, so you can see that indeed it is 12 volts. So then I will measure the voltage across resistor 1, the 1K resistor, so I get 4.81. So let me write that down here. And then the voltage across resistor 2, which is that one, so that's 7.19. 7.19. And then the voltage across resistor 3, which is also a 7.19, which kind of is as what I had hoped. Okay, looking at my circuit diagram again, we've got the 12 volt source in, we've got voltage, or the resistor 1, resistor 2, resistor 3. I've placed on the diagram the plus to minus for resistor 2 is, or I guess that's 3, that direction. Plus to minus for resistor 1 and plus to minus for resistor 2, which is the way I measured them. That is, the red lead went where the plus sign is. I've then recorded those in the table, 11.1. Again, these values aren't the same as you're going to get because I used a different resistor for R3. But I'm just writing down the voltage for resistor 1, 2, and 3. And the next I'll measure the voltages with power supply B only, so that would be changing the circuit to this, and that is I'm going to remove power supply A, replace it with a short to ground, and then using the same resistors, I'll now replace power supply B at 6 volts and take those same measurements. Okay, looking at my circuit, I've replaced power supply A with the short wire, or the short circuit to ground, that is the wire. I've reconnected power supply B, and I'll measure the voltage across it so that we verify that it is in fact 6 volts. And well, 6.01, we're 1/100 of a volt off, but I'll learn to live with it. There again, we need to mark the polarities of the voltages coming in. I'm going to use the same polarity, and what we'll find out is, because now that the power supply is over there, if I measure V1 this way, now I get a minus 1.63. So it is the reverse voltage that I got when I measured it with the power supply A connected. When I measure voltage 2, it too is a minus. So that's minus 4.37. And voltage 3, or the voltage cross resistor 3, is now, again using the same polarity, 1.63. Okay, so again I will record those voltages in my table. I've put in the voltages using the same polarities that I measured, because I used the designated plus and minus sides of those resistors. So we've got a minus 1.63. When we add that to 4.81, we know that when we add a negative number, that's subtraction. So I get 3.18. I have 7.19 minus 4.37, so I get 2.82. And then 7.19 plus 1.63, so I get 8.82. Now I will connect the original circuit, and we're going to measure what really happens when we have both supplies connected.